All right, guys. So one more practice with trig equations. Again, we are solving for missing angles given the ratio. So this takes us right back to the beginning of when we first started studying trigonometry. So I'm just going to run through some examples with IXL. All right. This tells me that the sine of theta is equal to negative 1/2. All right. Sine of theta equals negative 1/2. So I basically need to look at my unit circle, right, and find where the sine of theta is equal to negative 1/2. All right. So this is definitely going to be in quadrants 3 and 4. And I believe, if memory serves me right, all right, if we think of our unit circle, those places are going to be, negative 1/2 is about right here. They're going to be here and here. So looks like that is at, and one other thing, almost missed it. It tells me need to have angles only between negative pi over 2 and pi over 2. All right, so this is negative pi over 2, and this is pi over 2. All right, so we're looking at where is the sine value equal to negative 1/2? Well, the only place between negative pi over 2 and pi over 2, which means we cannot count these guys, would be here. So this would be at negative pi over 6. All right. On your unit circle, that would say 11 pi over 6. However, it's asking you, only give me angles between negative pi over 2 and positive pi over 2. So we're going to go ahead and enter that as negative pi, then negative pi over 6, and loves me. Okay. This next one is looking for degree format, right? It's asking, when's the sine of theta equal to 1/2, right? The positive 1/2, right? And so this is at 30 degrees. If you check your unit circle, you'll see that that is correct. Okay. It asks you for where's the cosine value equal to 1, somewhere between 0 and pi. And you would say, well, that's at 0. Okay. All right. And then it seemingly gets a little more difficult, right? By throwing in a negative 12. Well, this isn't really a big deal when your equation set equal to 0 anyways. So you can really just say divide both sides by negative 12, and you have sine of theta equals, well, 0 divided by negative 12 is still 0. So you're still looking for a sine value that gives you 0, somewhere between negative 90 and 90. And that's actually going to be at 0 degrees. All right. Again, all of this you can check with a unit circle by your side. Okay. They start getting a little more advanced. You can check this one out. All right. So this guy says 7 cosine of theta plus 7/2 equals 0. So what I'm going to do is I'm just going to, I want to get these in a simple cosine of theta equals or sine of theta equals. So I'm going to move the 7/2 to the other side. So I got 7 cosine of theta equals negative 7/2. All right. Then divide both sides by 7. All right. And that gives me cosine of theta equals negative 1/2. All right. When I divide a 7 to the other side. So again, this is as easy as one of the first problems. All right. And let's jump up a level or 2. All right. See how we're doing. All right. See right here, we got some cosines on both sides. All right. Have no fear. All right. We treat it as a regular equation. So we're going to say negative 11 cosine of theta. We're going to go ahead and add 11/2 to both sides. All right. So adding 11/2 to negative 4/2 will give you positive 7/2 equals negative 18 cosine of theta. We're going to add 11 cosine of theta, so 7/2 equals negative 7 cosine of theta. Divide both sides by negative 7, and you've got negative 1/2 equals cosine of theta. So this actually is just like the previous one, all right, if you just treat this as like terms. So that's how you solve trigonometric